With this video, we're going to go through the entire lesson of the vertex. We're going to find vertex, axis of symmetry, and y-intercept, all three. So we're going to go through the entire lesson on this, and that would give you a chance to kind of review it all. All right, so let's kind of bring in some information that we need to know here. First, we've got to be able to determine what a vertex is. So I've got two different graphs, specifically parabolas. One that is a smiley face and one that's a frowny face. Now, the vertex on a parabola is either the very highest point or the lowest point. In this case right here, this is the lowest point on the graph. The vertex on the next one here, that is the highest point on the graph. So either way, if it's a smiley face, the vertex is going to be the lowest point on the graph, and if it's a frowny face, the vertex will be the highest point on the graph. All right, the next thing that we need to worry about here is something called an axis of symmetry. In an axis of symmetry, if we take the vertex and we draw a vertical line straight up and down, we'll find out this is what we call the axis of symmetry. And that blue line there indicates the axis of symmetry. The parabola is exactly the same. It's like a mirror image on both sides when we draw that axis of symmetry straight down. And same thing if it's a frowny face, we draw that line straight up and down. Both of those are an axis of symmetry. So the big thing with the axis of symmetry, we'll kind of get into that in just a moment, is we have to find the vertex first. From there, we can determine what our axis of symmetry is. All right, we do a little wavy thing here. Okay, we need to be able to identify, this is going to become crucial, to identify what A, B, and C is in a given quadratic. So let's kind of go through an example here. The example is I've got this y equals 2x squared plus 3x minus 5. A is the very first number, the leading coefficient. That's the first number, the number right before the x squared. It's the one in red up top now. In the actual slide, it's the number 2 here. B would be the number before the x, or the linear term. In this case, it would be a 3. And C would be the one that doesn't have any variable next to it. In this case, it's negative 5. Okay, so take a second and kind of see where I got all three of those. Now, I'm going to give you some, just to give you a little bit of practice. So I'm going to give you two more equations here. Here are the two equations. What I want you to do now is go ahead and pause the video. Write down what A, B, and C are. That way we can kind of get a little bit of practice. Once you've figured out what those are, then come back and push play on the video again, and we can check your answers. Okay, so hopefully you found out that in that first one, the negative 1 was the number in front excuse me, of the x squared. Negative 5 was our b value, and 2 was our c value. The second one here was a little bit tricky, only because we did not have a c value. If you notice there is no number that is just a number that doesn't have that variable next to it. We had a 1, the negative 3 was our b value. C, in this case, which is 0. If there is no value there, 0 is the number that we'll use for it. All right, now we're going to try two more. Let's bring in these two. I want you to work on these two. Push pause, and then when you're ready, come on back and push play again. All right, looking at these, if you'll notice on that, the one with the negative x squared plus 4, the b value is 0. There is no b value there. We do have the c value, though. The c value, that 4, does not have any linear term next to it. It doesn't have any x next to it. So that is just 4. That's going to be our c value. Now, in the last one there, we did not have a b value nor a c value. We just had the a value, and that was it. So the rest are 0. So again, if you don't have a number there, your value there is 0. All right, so let's bring one in now. We're going to work on finding the vertex. We're going to do this by hand. A little bit later on, we're going to show you how to use the calculator on it. But first, let's do it by hand. So we have a given problem here. Remember, the vertex is either the highest or the lowest point. This one's a smiley face. So in other words, it's going to be the lowest point. All right, so let's bring one in. The following formula is what we'll find the x value of a vertex. A vertex has an x and a y value. So this is the x value. It's negative b divided by 2a. Now you can start to see why we need to identify what the a value is, what the b value is, and what the c value is. All right, so let's bring in our example. Our example here is x squared plus 4x plus 8. All right, so First we have to do is identify our A, B, and C. Our A in this case would be 1, our B value would be 4, and our C value is 8. Okay, now that we have that, we can use this to plug it into our vertex formula. So here vertex is x equals, and then it's negative b divided by 2a. So this is going to be negative 4 divided by 2 times 1. Okay, and I'm just plugging in my values for b and a there is all I'm really doing. You'll notice how I have the subtraction sign way out in front. If you want to, and it makes it easier for you to put that negative value up by the 4, that's fine. That doesn't hurt at all. Either way is okay. So we find out that our x value is indeed 2. So now that we know what the x value is, we can determine what the y value is. What I'm going to do is take that 2 and I'm going to plug it in for x in that equation there, the one in green, x squared plus 4x plus 8. Okay, and I'm going to plug it in to each spot. We'll bring that in. Instead of writing x, I know what x equals. X equals negative 2, so I'm going to write that in for x instead. And then all I have to do is simplify it. Well, negative 2 squared is 4, and then I've got 4 times negative 2 is negative 8. So I end up with a 4 minus 8 plus 8, which gives me a y value of 4. So now I know my vertex. My x value is 2. My y value is 4. And I got those directly from those. Look at those red arrows there. That's where I got those two. All right, so we've just found the vertex of this one. Well, that's the hard part. Once we find the vertex, then the axis of symmetry is really easy. The axis of symmetry, if you remember, is a straight line right down the middle of that vertex. And if the vertex, the x value is negative 2, our axis of symmetry is going to be a vertical line right there. Now, if you remember the vertical lines, that means it's going to be a vertical line right at x equals negative 2. So the axis of symmetry in this case is going to be x equals negative 2. That's my axis of symmetry. Okay, that is a vertical line right straight down the vertex in this case. Now, finally, the last thing I'll ask for is the y-intercept. So the y-intercept here, now we have to remember about the y-intercept. The y-intercept always occurs where x equals 0. So we have that equation up there in green, the y equals x squared plus 4x plus 8. All we need to do is plug in 0 for each of those x values. Well, 0 squared is 0, plus 4 times 0 is 0. So I end up with just my c value in this case. So y would equal that 8. Well, if y equals 8, what is my x value? Remember, the vertical intercept is a distinct point. It is one point there, so my y-intercept in this case would be 0, 8. And that's going to be important. You will write it as, in parentheses, 0, 8. And now what we're going to do is we're going to transition just a little bit here. I've got 2 here I want you to practice on. I want you to come up with all 3. I want you to come up with the vertex, the axis of symmetry, and the y-intercept. Okay, so push pause now. Once you get your answer, then you can come back and push play. And you can check your answer on both of these two. Okay, check your answer here to make sure this is what you've got. One important note here, the axis of symmetry is not 1, it is x equals 1. So it must be written as x equals 1. That's a vertical line. As well, the y-intercept is not 2. The y-intercept is actually a distinct point, so it should be parentheses 0, 2, close parenthesis for number 1. And same thing on number 2. You'll notice that's the only way that I'll accept the answer. Alright, so let's try another one now. Let's bring another one in here. Push pause now. Work this answer through. Whenever you get the answer, then you can push play again. Check your answers on these two. Alright, now this one, the vertex is 0, 0. This throws some students for a loop because the b value is 0. Well, 0 divided by anything is just 0. So then you have an x value of 0, and if you plug in 0 for x, you end up with a y value of 0 as well. So your vertex is 0, 0. Then your axis of symmetry is 0, 0, and your y-intercept occurs where x equals 0, which is the exact same spot as your vertex. Those two matched on number 1. Number 2, the big thing is you have to remember to write your y-intercept as, in parentheses, it's an ordered pair 0, 1, and of course the axis of symmetry has to be written as x equals as well. Alright, now we're going to give you a real-life equation here. So this is a military's dropping off a care package. Here's the equation that models the time that it's going to take. So I want you to find the vertex and then describe its meaning. What does it mean? So first thing you have to do is find that vertex, and then we can describe what it is. So go ahead and push pause now. I want you to find the vertex. Then we'll come back and determine its meaning. Okay, check your answers here. Hopefully you found out that the vertex was 0, 135. Now this is important, but this is not the whole problem. The whole problem is that we have to explain its meaning. So if we look up just a little bit above where it says finding the vertex, right there it says y equals the feet above the ground, and t represents the time in seconds. Okay, so our t value here, and t is basically replacing x. If you'll notice in the vertex, I just replaced the t with the x, and that works just fine. So the t value is our x. So it says we have to interpret this. It goes 0, 135. Well, the 0 represents our x, or our t in this case. T is the time in seconds. So at 0 seconds, comma, and then 135. 135, and that says y represents the feet above the ground. So at 0 seconds, the package was 135 feet above the ground. So basically, right before they dropped the care package, they were 135 feet above the ground. All right. That one takes some practice, so you'll want to get some practice, especially on the homework on those. Now let's bring in the calculator. I'm going to model this one on the calculator and show you how to find a vertex using your calculator. Now I'm going to do the TI Inspire first. After the entire video at the end, then I'll add in the TI-84 to kind of show you how to use this. I know most of you have the TI Inspire, so I'm going to model that one at the end. If you want to, you can just look it up on the TI-84. They'll both be on this one. Right now we're going to be looking at trying to graph this equation. I've got it down here, the one in green. We're going to graph that equation, and we're going to try to find the vertex of it. And this is using the TI Inspire, so this only works for the Inspire, but here's our equation down here, and what we want to do is we want to go ahead and type that one in. And so I'll do that now. I'm just going to write negative. Remember, this is your negative sign. Don't use the minus sign, but the negative. 3. X is down here on toward the bottom. These are all your alpha keys. Squared plus 6x, 6x plus 2. Okay, when I have that entered in there, you'll see this is our f of x. That's our function notation. Then we'll hit enter, and it'll kind of give us a graph here. And we're going to look at this graph now, and we want to try to find the vertex. And the vertex is either the highest or the lowest point. In this case, it would be the highest point because this is a graph. This is a frowny face. This opens down. So we're looking for the highest point. The way we'll do that on the calculator is by looking for the maximum, the very maximum point on this graph. So we'll go in here to our menu button, and this drops down a menu for us. We want to go to Analyze Graph. And we're looking for the maximum. We're looking for the maximum because this one is a frowny face. If this one were a smiley face, we'd be looking for the minimum. Now down here in the lower left-hand corner, it says lower bound. So we're looking for the left-hand side of the vertex. We know the vertex is going to be somewhere around there. We're going to look at the left-hand side. So as long as you click anywhere along here, that's where we'll start. Now it says upper bound. Now notice whenever I move this, that my cursor creates the shaded in area. And what we're looking for, the computer is going to analyze this graph. Anywhere that it's shaded in, it will analyze the very maximum point in between that shaded in portion. So as long as we cover the vertex with that, we should be fine. So anywhere over here would be okay, and then we just click it there. And it tells you that the maximum point is right here at 1, 5. Okay, 1, 5 is our vertex, and we can look down here, and our vertex on that one was 1, 5. And we have to use parentheses in your answer, otherwise it will mark it wrong. Okay, and that's basically how you do it. You just go to the menu button, go to Analyze Graph, Maximum, lower bound, you just have to pick somewhere on the left-hand side. You go to the upper bound, somewhere on the right-hand side, and it magically finds it for you. There's our vertex, that 1, 5. Okay, so now we're back to some more real life. We've got Katniss here, and this is from the movie, either Catching Fire or any of the books that were written. But Katniss is target practicing. She shoots an arrow into the air. And I've got this equation here that models the flight of the arrow. And important parts here, h of t represents the height in feet above the ground. This is important whenever we get into the practical meaning. So h of t represents the height in feet above the ground, and t represents the time in seconds. Okay, so this is real similar to the one that we did earlier, where we did the care package that we were dropping. Okay, so what we want to do here is we need to determine what the practical meaning of the vertex is. Well, in order to find the vertex, you can plug that one into your calculator. That's probably going to be the easiest way to do it. Then we're going to have to interpret this. Now I'm going to rewind just a second so you can remember what h of t and what t represent, because you're going to get that ordered pair. Okay, so here we go. Remember, h of t represents the height in feet above the ground, and t represents the time in seconds. Okay, so go ahead and find the vertex on this one, and try to work through it and see if you can find what the practical meaning is on this one. Go ahead and push pause when you're ready to come back. Push play. Okay, on this one, hopefully you found out that this one was a frowny face, and the way that we determine the frowny face is the value of a. In this case, a is -16. Now this one's kind of written out of order, but it's important to recognize your a value. So this one is a frowny face. The vertex on this one, hopefully you found out that it was 3, 149. So we've got to determine what is 3. Well, 3 is t. That's our t value. T was the time in seconds. Okay, so after she shoots this, 3 seconds is what it is. So 3 is the time in seconds. 149, that is the feet above the ground. So our practical meaning of this one, and we just kind of write a sentence using those two. After 3 seconds, the arrow reached 149 feet. Now this was the maximum height because it's a vertex. So after that, the arrow started coming back down toward the ground. All right. And really, if you can just separate those two and write, okay, 3 is time in seconds. I always write those out. 3 is time in seconds. 149 is the feet above the ground. And then write something. At 3 seconds, the arrow was 149 feet off the ground. Something along those lines is what I'm looking for. Okay, so for the next problem, we're going to build off that same exact concept. This is still Katniss shooting the arrow. But we want to know what the practical meaning is. What's the significance, the practical meaning of the vertical intercept? Now, the vertical intercept is the y-intercept. This is where it crosses the y-axis. All right, and that becomes important. Again, we still have our frowny face here. The vertical intercept, or the y-intercept, occur where x equals 0, or in this case, where t equals 0. So if we were to plug in 0 for t in that equation, we would end up with a y value of 5. So our vertical intercept right here is 0, 5. All right, now we need to just write down what each one of those mean. 0, again, is the time in seconds. That was our y value, or our h of t. So 0 is the time in seconds. 5 is the feet above the ground. Now we need to figure out what that practical meaning is. Write a sentence. At 0 seconds, it was 5 feet above the ground. That's decent, which basically means at 0 seconds, this is right before she shot it, because once she shoots it, it's no longer 0 seconds. There's some sort of time value there. So if you want to, the best way to write it would be something along the lines of the arrow was shot from 5 feet above the ground. All right, we're going to bring in one more real-life example here, and that way we can get a little more practice on it. A softball is hit straight up over home plate. The path of the ball can be modeled using this following equation. H of t represents the height in feet above the ground, and t represents the time in seconds. So that's important. You need to find what the practical meaning is of the vertex. So finding the vertex is not enough. We've got to find the actual practical meaning of it. So I want you to push pause right now. And then when you found the vertex and found the practical meaning, come on back and we can review it. Okay, hopefully you found out that the vertex was this 2.19, something along there. Now, I didn't ask you to round it, but as long as you get somewhere close there, I'm happy. And then 80.56 is the t value, excuse me, the y value, or the h of t value. So now we just have to kind of write what each of those mean. Well, 2.19, that's the seconds. Remember, that's our t value in this case, time in seconds. And 80.56 is the feet above the ground. So you should have something close to this, and it doesn't need to be exactly this, but something close to the fact of after 2.9 seconds, the ball reached a maximum height of 80.56. If you wrote something along the lines of after 2.19 seconds, the ball is 80.56 feet above the ground, I'd like that. That's good. You're not writing something in there about the maximum height, which I'd like to see because that's what the vertex is. It's the maximum height. After that, it came back down. But you're on the right path there. All right, so this will conclude the lesson other than the TI-84. I'm going to show you how to do that right now. If you want to go back in and just review this lesson as many times as you'd like, or watch any of the other videos that I have. Okay, right now we're working on finding the vertex. We're going to use our calculator to do this one. Now here is our quadratic function here. We've got h of x equals x squared plus 2x minus 8. Okay, so I'm going to turn on my calculator, and I'm going to go right to the y equals screen right here. So it should look like that. I have a formula already in there, so I'm going to clear that one out. I don't need that one. Now I'm going to type in that formula, so I'm going to go x squared plus 2x plus 2x minus 8. I've got that one in there. I'm going to hit graph, and we'll see what the graph looks like. Hopefully it'll be on the screen, and it is. Now what we're going to do is we're going to just find the vertex. So we're going to go to second trace is the two buttons that I'm going to use here. I go second trace, and that gives me calculate. And I need to determine whether this one is a minimum or a maximum. I don't remember, so I got to go back to the graph. If I look right here, the graph goes down in this direction and then back up. So this would be a minimum point right here. So I'm going to go back to second trace, and now I'm looking for option number 3, which is my minimum point. Okay, I scroll down. You can just type in 3 if you want. Now I hit enter, and it's going to say left bound. That means I need to be at least on the left side, on this side of the lowest point. So I'm just going to scroll over. It doesn't really matter where. Right here's my cursor. I'm definitely on the left-hand side at this point, so I hit enter. Now it says go to the right side. Now I got to scroll over in this direction. I need to have some point on this side. It doesn't really matter which one. You hit enter, and it says, would you like to guess? And say, of course, we'd love to guess. Then it pops up here, and it says our minimum point is -1, -9. -1.00000, and then -9. So your vertex on this one would be -1, -9. Okay, that's your lowest point.